you've estimated that we'll have AGI by 2030. So there's interesting questions around that. How will we actually know that we got there? And what may be the move 37 of AGI?
My estimate is sort of 50% chance in the next 5 years. So, by 2030, let's say. And so I think there's a good chance that could happen. Part of it is what is your definition of AGI? Of course, people are arguing about that now. And mine's quite a high bar and always has been of can we match the cognitive functions that the brain has? Right, so we know our brains are pretty much general Turing machines, approximate. And of course, we created incredible modern civilization with our minds. So that also speaks to how general the brain is. And for us to know we have a true AGI, we would have to make sure that it has all those capabilities. It isn't kind of a jagged intelligence where some things it's really good at, like today's systems, but other things it's really flawed at. And that's what we currently have with today's systems. They're not consistent. So you'd want that consistency of intelligence across the board. And then we have some missing, I think, capabilities, like sort of the true invention capabilities and creativity that we were talking about earlier. So you'd want to see those. How you test that? I think you just test it. One way to do it would be kind of brute force test of tens of thousands of cognitive tasks that we know that humans can do, and maybe also make the system available to a few hundred of the world's top experts, the Terence Taos of each subject area, and see if they can find, give them a month or two and see if they can find an obvious flaw in the system. And if they can't, then I think you're pretty, you can be pretty confident we have a fully general system.
Maybe to push back a little bit, it seems like humans are really incredible as the intelligence improves across all domains to take it for granted. Mm-hmm. Like you mentioned, Terence Tao, these brilliant experts, they might quickly, in a span of weeks, take for granted all the incredible things it can do and then focus in, haha, right there. I consider myself first of all, human.
Yeah.
Second, I identify as human. Some people listen to me talk and they're like, that guy is not good at talking, the stuttering, so even humans have obvious across domains limits, even just outside of mathematics and physics and so on. I wonder if it will take something like a move 37, so on the positive side, versus like a barrage of 10,000 cognitive tasks where it would be one or two where it's like,
yes,
holy shit, this is special.
Exactly. So I think there's the sort of blanket testing to just make sure you've got the consistency. But I think there are the sort of lighthouse moments like the Move 37 that I would be looking for. So one would be inventing a new conjecture or a new hypothesis about physics like Einstein did. So maybe you could even run the back test of that very rigorously, like have a knowledge cutoff of 1900 and then give the system everything that was written up to 1900 and then see if it could come up with special relativity and general relativity, right? Like Einstein did. That would be an interesting test. Another one would be, can it invent a game like Go? Not just come up with Move 37, a new strategy, but can it invent a game that's as deep, as aesthetically beautiful, as elegant as Go? And those are the sorts of things I would be looking out for, and probably a system being able to do several of those things, right, for it to be very general, not just one domain. And so I think that would be the signs, at least that I would be looking for, that we've got a system that's AGI level. And then maybe to fill that out, you would also check the consistency, make sure there's no holes in that system either.
Yeah, something like a new conjecture or scientific discovery. That would be a cool feeling.
Yeah. That would be amazing. So it's not just helping us do that, but actually coming up with something brand new.
And you would be in the room for that. And so it would be like probably 2 or 3 months before announcing it. Mm-hmm. And you would just be sitting there trying not to tweet.
Something like that. Exactly. It's like, what is this amazing new, physics idea? And then we would probably check it with world experts in that domain, right? And validate it and kind of go through its workings. And I guess it would be explaining its workings too. Be an amazing moment.
Do you worry that we, as humans, even expert humans like you, might miss it might miss?
It may be pretty complicated. So it could be, the analogy I give there is, I don't think it will be totally mysterious to the best human scientists, but it may be a bit like, for example, in chess, if I was to talk to Garry Kasparov or Magnus Carlsen and play a game with them and they make a brilliant move, I might not be able to come up with that move, but they could explain why afterwards that move made sense. And we would be able to understand it to some degree. Not to the level they do, but if they were good at explaining, which is actually part of intelligence too, is being able to explain in a simple way that what you're thinking about. I think that would be very possible for the best human scientists.
But I wonder, maybe you can educate me on the side of Go. I wonder if there's moves from Magnus or Gary where they at first will dismiss it as a bad move.
Yeah, sure, it could be. But then afterwards, they'll figure out with their intuition that why this works, and then empirically, the nice thing about games is, one of the great things about games is it's a sort of scientific test. Do you win the game or not win? And then that tells you, okay, that move in the end was good. That strategy was good. And then you can go back and analyze that and explain even to yourself a little bit more why, explore around it. And that's how chess analysis and things like that work. So perhaps that's why my brain works like that, because I've been doing that since I was 4. And you're trained, it's sort of hardcore training in that way.
But even now, like when I generate code, there is this kind of nuanced, fascinating contention that's happening where I might at first identify as a set of generated code as incorrect in some interesting, nuanced ways. But then I'm always have to ask the question, is there a deeper insight here that I'm the one who's incorrect?
Mm-hmm.
And that's going to, as the systems get more and more intelligent, you're going to have to contend with that. It's like, what do you, is this a bug or a feature what you just came up with?
Yeah, and they're going to be pretty complicated to do, but of course it will be, you can imagine also AI systems that are producing that code or whatever that is, and then human programmers looking at it, but also not unaided with the help of AI tools as well. So it's going to be kind of an interesting, maybe different AI tools to the ones that they're more, kind of monitoring tools to the ones that generated it.
So if we look at an AGI system, sorry to bring it back up, but Alpha Evolve, super cool. So Alpha Evolve enables, on the programming side, something like recursive self-improvement, potentially. Like what, if you can imagine what that AGI system, maybe not the first version, but a few versions beyond that, what does that actually look like? Do you think it will be simple? Do you think it will be something like a self-improving program and a simple one?
I mean, potentially that's possible, I would say. I'm not sure it's even desirable because that's a kind of like hard takeoff scenario.
Yeah.
But you these current systems like Alpha Evolve, they have, human in the loop deciding on various things. They're separate hybrid systems that interact. One could imagine eventually doing that end to end. I don't see why that wouldn't be possible. But right now, I think the systems are not good enough to do that in terms of coming up with the architecture of the code. And again, it's a little bit connected to this idea of coming up with a new conjectural hypothesis. How they're good if you give them very specific instructions about what you're trying to do. But if you give them a very vague, high-level instruction, that wouldn't work currently. And I think that's related to this idea of invent a game as good as Go, right? Imagine that was the prompt. That's pretty underspecified. And so the current systems wouldn't know, I think, what to do with that, how to narrow that down to something tractable. And I think there's similar, look, just make a better version of yourself. That's too unconstrained. But we've done it in as you know, with Alpha Evolve, things like faster matrix multiplication. So when you hone it down to a very specific thing you want, it's very good at incrementally improving that. But at the moment, these are more like incremental improvements, sort of small iterations. Whereas if you wanted a big leap in understanding, you need a much larger advance.
Yeah, but it could also be sort of, to push back against hard takeoff scenario, it could be just a sequence of incremental improvements, like matrix multiplication. Like it has to sit there for days thinking how to incrementally improve a thing, and that it does so recursively. And as you do more and more improvement, it'll slow down.
Right.
So there'll be the path to AGI won't be it'll be a gradual improvement over time.
Yes. if it was just incremental improvements, that's how it would look. So the question is, could it come up with a new leap, like the Transformers architecture?
Yeah.
Right? Could it have done that back in 2017 when, we did it and Brain did it? And it's not clear that these systems, something like AlphaVault, wouldn't be able to make such a big leap. So for sure, these systems are good. We have systems, I think, that can do incremental hill climbing. And that's a kind of bigger question about, is that all that's needed from here? Or do we actually need one or two more big breakthroughs?
And can the same kind of systems provide the breakthroughs also? So make it a bunch of S-curves, like incremental improvement, but also every once in a while leaps.
Yeah, I don't think anyone has systems that can have shown unequivocally those big leaps. Right, we have a lot of systems that do the hill climbing of the S-curve that you're currently on.
Yeah, and that would be the Move 37, isn't it?
Yeah, I think it would be a leap, something like that.
Do you think the scaling laws are holding strong on pre-training, post-training, test time, compute? Do you, on the flip side of that, anticipate AI progress hitting a wall?
We certainly feel there's a lot more room just in the scaling. So actually all steps, pre-training, post-training, and inference time. So there's sort of three scalings that are happening concurrently. And it's about how innovative you can be. And we pride ourselves on having the broadest and deepest research bench. We have amazing, incredible researchers and people like Noam Shazir, who, came up with Transformers, and Dave Silver, who led the AlphaGo project and so on. And it's that research base means that if some new breakthrough is required, like an AlphaGo or Transformers, I would back us to be the place that does that. So I'm actually quite like it when the terrain gets harder, right? Because then it veers more from just engineering to true research and, research plus engineering. And that's our sweet spot. And I think that's harder. It's harder to invent things than to fast follow. And so we don't know. I would say it's kind of 50-50 whether new things are needed or whether the scaling the existing stuff is going to be enough. And so in true kind of empirical fashion, we're pushing both of those as hard as possible. The new blue sky ideas, and maybe about half our resources are on that, and then scaling to the max the current capabilities. And we're still seeing some fantastic progress on each different version of Gemini.
That's interesting the way you put it in terms of the deep bench, that if progress towards AGI is more than just scaling compute, so the engineering side of the problem, and is more on the scientific side where there's breakthroughs needed, then you feel confident DeepMind as well. Google DeepMind is well positioned to kick ass in that domain.
Well, I mean, if you look at the history of the last decade or 15 years, it's been, maybe, 80-90% of the breakthroughs that underpins modern AI field today was from, originally Google Brain, Google Research, and DeepMind. So, yeah, I would back that to continue, hopefully.
So on the data side, are you concerned about running out of high quality data, especially high quality human data?
I'm not very worried about that, partly because I think there's enough data and it's been proven to get the systems to be pretty good. And this goes back to simulations again. Do you have enough data to make simulations, or so that you can create more synthetic data that are from the right distribution? Obviously, that's the key. So you need enough real world data in order to be able to create those kinds of data generators. And I think that we're at that step at the moment.
Yeah, you've done a lot of incredible stuff on the side of science and biology, doing a lot with not so much data.
Yeah.
I mean, it's still a lot of data, but I guess enough to
get that going. Exactly.
Yeah.
So exactly.
How crucial is the scaling of compute to building AGI? This is a question that's an engineering question. It's almost a geopolitical question because it also integrated into that is supply chains and energy, a thing that you care a lot about, which is potentially fusion. So innovating on the side of energy also. Do you think we're going to keep scaling compute?
I think so, for several reasons. I think compute, there's the amount of compute you have for training, often it needs to be co-located. So actually even like, bandwidth constraints between data centers can affect that. So there's additional constraints even there. And that's important for training, obviously, the largest models you can. But there's also, because now AI systems are in products and being used by billions of people around the world, you need a ton of inference compute now. And then on top of that, there's the thinking systems, the new paradigm of the last year that where they get smarter the longer amount of inference time you give them at test time. So all of those things need a lot of compute. And I don't really see that slowing down. And as AI systems become better, they'll become more useful and there'll be more demand for them. So both from the training side actually is only just one part of that. It may even become the smaller part of what's needed in the overall compute that's required.
Yeah, that's one sort of almost meme-y kind of thing, which is like the success and the incredible aspects of VO3. There's like, people kind of make fun of like the more successful it becomes, the servers are sweating.
Yes, exactly.
To do the inference.
yeah, exactly. We did a little video of the servers frying eggs and things, and that's right. And we're going to have to figure out how to do that. There's a lot of interesting hardware innovations that we do. As you know, we have our own TPU line, and we're looking at like inference-only things, inference-only chips, and how we can make those more efficient. We're also very interested in building AI systems, and we have done the help with energy usage. So help data center energy, like for the cooling systems, be efficient, grid optimization, and then eventually things like helping with plasma containment fusion reactors. We've done lots of work on that with Commonwealth Fusion, and also one could imagine reactor design. And then material design, I think, is one of the most exciting. New types of solar material, solar panel material, room temperature superconductors has always been on my list of dream breakthroughs, and optimal batteries. And I think a solution to any, one of those things would be absolutely revolutionary for, climate and energy usage. And we're probably close, again, in the next 5 years to having AI systems that can materially help with those